Hello guys, how you doing? Welcome back. As you can see, that's the first exercise. So let's get into it. Let's go into it. You know, so this the first quiz, a proton, a deuteron, and. So I will show you this. I already write steps to make to avoid the time consuming. So first time you have to write the given information. It is right in here, My charge is E. It's not electron, but just E. There's a mass MP. Then what you have to do is then second step. So basically the second step what I did is I used the conservation of energy formula. So I said in beginning it was not moving. So it's very in the beginning. So in situation one, I say that my V was 0 and my ePod was not working, It was like it was not there, I mean, it was not moving, so I assume that it was not that was not a position difference. So 0 0. And then I put this equal to the second situation where they say that I think here that this particle are accelerated by the same potential difference. It means that that the moving situation was in the same situation as the potential difference. So potential difference make sure that the particle is moving, you know. So this is my particle from minus to plus example, and this is my kinetic energy, mass times V squared divided by 2. So that's the formula that I use. So first, yeah. Then you have this. So basically, I said minus Q times the potential difference because that's basically the general formula for the equal for um, basically in a potential difference, And I just put this on the other side and I make it equal to each other. Then I find V, I mean the velocity. Then you have to put this like this. Then you have to do like this. Then if you find this one, you can find the velocity of proton. Okay, next one. Then you have the third step. You have to make sure that the force, like I underline this here, I say that there is a uniform magnetic field. So basically, there is my magnetic field is perpendicular to my velocity of my charge. So basically, it's P times V, and they are perpendicular to each other. I mean, like this, perpendicular. Mm. Okay, so um, so yeah, I put this equal to each other. We have the first circular force. So it means that when you see that a particular, when you see that a charge is moving in a circular form, then you have to use this one, And then I put this like this, Then that's the fourth step. So I basically was based on this one. So this one is also a general formula for my radius. I mean my radius, yeah, radius. And I just find this was the fourth step is just basically for the proton. So mass times velocity divided by the charge. Charge was like here, and I mean here, and divided by charge times the B. So it's pretty equal to this one. Then I remember that the V from the V and the V there was equal to, for proton is equal to that, you know. So basically I put this here and then it gives me the final answer. But before that you have the final answer, you have just to know that when you have MP over there and MP over there in a root, you just have to calculate like this, you know, because MP is there and, you know, then you will understand that it will be this, you know, and your final answer for VP, RP, radius P is this, you know, but it's not finished. It's not finished. So yeah, that's the first step. So we are not in the first step, we are in the five step, in the fourth step. Fourth step is RP is equal to 1 over B. Then you know this formula. Then so from the previous one, you know. Then what you have to do is to do it for deuteron. So the mass was 2 times the mass of the proton and charge is E, not the electron, but just E. Then you have this one. I would take the conservation of energy formula. Where I did this, you can see this. And then I did this. I did this. Just the velocity of deuteron. Then you have to do this one too. This F, you know, magnetic force is equal to the circular force, you know. Then you have this step. You finally have to find the radius for deuteron. This one. Then you have also a little info that I put here. If you have this one, you can find it by doing the roots of 2 times root of 2 to give you automatically 2. So divided by, you know, I'm going to show you what I mean. That's what I did here. So basically I did here the root of 2 divided by b, and then I put some 2 there to make equal to this one, the previous one, you know. And it's also the answer. You just to do this just for these 2 and you will find the sample. I mean the same way. This is just the same way. So yeah, same way. Okay, so here we go. Here are the second exercise, and let's get into it. So first of all, you have to visualize the situation. I don't know if you can read this text, but you know, there, you know, this text here. And what I draw was just the screen. It was just the height. The height is 0.90 meters. And what they ask is what is the, you know, different distance, you know. And this height is also equal to the 0.90 meters. Then you have the radius is I call this R, you know, R. And what I did also is I knew that this distance, this distance and this distance was equal to each other, you know, but I divided in 2 segments, the distance that we're looking for, and another another value that we don't know, you know. So let's go. Second step is just, I don't know if you can see it good. Second step is like you have to do like this. So you have to use the same formula, conservation of energy, kinetic energy, and the potential difference. you have to make sure that velocity is equal to the roots of this formula. Then I write it for you, the steps. Before I will go further, don't forget to, to make it, you have to run it, you have to make it to this, not using this, but this, Okay, second one. The third one is just it's just the same, little bit same formula as the previous exercise. So R is equal to the mass times the velocity over the Q charge, times the magnetic field. So I write it here. So there's the mass of my charge. This is just the velocity. This is the charge. This is the magnetic field strength, or the magnetic field that's induced. Then you have also the fourth exercise. Fourth exercise is the last step, you know what I'm saying? So what I did is just using the Pythagoras. So, you have the triangle, you have the, triangle, and you just have to find the longest side, edges, short edges. But in this one, you have to find these edges, these edges, you have to find it. What I did was I knew that there will be a distance between these two edges. So what I did is just r minus x, because x, so we don't know, but it's nearby this distance. So then you have to do this. Maybe if you don't understand, if you can read what I write, just 0.19 to the square, and then then you have to take your r, because r is much larger than your x. You have to do this like this, minus this x, and you will be, we will have this one. It's the same step for part B also, so don't worry, you'll be fine. So let's go for the next one. Okay, guys, this is the chart exercise. So let's get it. Okay, let's get it. So the first one. So in this situation, they are talking about let me see, talking about the magnetic field, because I read it. It was the spectrometer, and they are talking about the centripetal force because they are curved. Here. These two are the reason why I chose this formula. Okay, let's go for the other one. So there's a step two. Step two is like, I just take the previous formula. The second step of the previous formula. I write it here, and what I did is I put this term in constant, because they only talk about radius and the mass, and we don't need to find B. B is not given, Q is not also given, and the velocities are not so given. But we can search and link between the mass and the radius, because the question is also which the distance, radius you can equal is like distance. So what I did is just taking these terms, because I know that mass and radius, they have a link to each other. I will show you why. So I think I did it like this because what? Because when you see 28.0, that is okay. 28. This one is a little bit lower than this one. I know that if your mass is greater than, if your mass is much higher, and your radius also is much higher, then they have to be the same. I will write this like you have 1/2 height. Okay, there is just a simple number. Then you have also 2/4, and this is a 2/4. This one. So this one is a 2/4, and this is 1/2 because when my mass is higher, my radius is also higher. You know, here. So I did like radius plus distance. You will see. You understand what I mean? So this is the greatest number, lowest number. Then the equation. You can read it. Just the equation. Of this one, and then you will find this one. Okay, I hope you understand it. Next, let's go over the next one. So yeah, everyone. So we are now in the fourth exercise. So let's get it. So for this one, I just started to looking at this figure. I will show you. So this figure, what I did here, it was just I just draw the circle, the inner circle and the outer circle. And yeah, with the first step, you just have to know that when you just have to maybe I could add this one and these arrows, but not important. Second step, so basically in this situation, you just have to use the Biot-Savart law. Biot-Savart law is this one there, this thing there, and then you have to know that the ds times r in the project, it will give you some perpendicular thing. So you can write this like this: ds times r, or otherwise ds times a, over my a to the exponent 3, and then I did it like this. Then you have this one, which is a circle. You have to know that we are working in a half circle, a semicircle. So not p times 2 times a, but p times a, or p times r. But in this case, we are talking about the a, so a, the inner circle. Then I write the BA for the inner circle, then the BB for the outer circle. And last stage you have to do is just like you have to do like this one, this. And then the second question was just, I think, how do you how I knew to choose this one, because the center is here. So you have just to look at the circle, not the outer, but the inner circle. And you will see that it will be off the screen. Okay, let's go to the next one. Okay, now we're finally in the fifth exercise. So let's back into it. So the first question is determine a formula for the field of points along the y-axis, such as point P. Basically, search the magnetic field in a direction. And that's step 1. Step 2, you have to use the Biot-Savart law. How did I do this? Basically, I knew that it was just a wire, and in this wire you can divide it by infinitesimal segments. So this segment will help you to find the total magnetic field in this inner direction. Inner direction. So as you can see, dl is equal to this E, because it's only working in this X direction. Then you have R, but I forgot to put here the vector, because it's just say that it was like it's just a vector, X component and Y component. Then you have to look at this one. That's 1/2. Okay. Then you have this. So just have to put this in this one. So if we just do this times this one, it will give you this one. And or just I mean this one to the exponent 3, and then it will give you this one. This is just a vector, you know. And then I did this like this. We know times E for P. Oh yeah, I forgot to say that minus D and 0 is just because minus D we are in a negative region. So I said minus D. And basically also the thing is, so you have minus D and then you have to 0, you know. And so we are always working in the dx, you know. Then this one times this one will give you 0. We don't give you any x I mean any x constants. But if you did dx times a y, then it will give you, that's basically e times y, you know. It will give you k direction, this. So yeah, it will give you this one. And then so basically we have 0, then we have this and this to give you just y dx, and it's finished, you know. And then you have to say that e times y is k, you know. Then just divide by the same things, you know. Then you have step 4. Step 4 just say that you have to use this. You have to calculate this, and it will give you this one. But what I did, I just put this y outside, and you know, so you can easily also know that. You see. That's a great. That's the, you know, that's the answer. Okay, next one. Oh yeah. Oh yeah, I forgot something. I forgot to say that you have also to put the d distance into the x component, and just that. And for the rest, it will be good. So yeah, we are in the final exercise. Just choose this one. Just choose this one, and you will be fine. Finally. Eh.